Hello listeners and welcome to the DrGPCR podcast. Did you hear about the DrGPCR University? It's the ultimate learning platform within the DrGPCR ecosystem. Here you can expand your knowledge, connect with experts, and stay informed about the ever-evolving world of GPCR research. We offer both live and on-demand courses covering everything from GPCR pharmacology data analysis to drug discovery strategies. Our courses, like those that focus on using Prism, help you master the pharmacology data analysis framework, navigate the complexities of GPCR research, and improve your work's quality, reliability, and efficiency. Join us and elevate your GPCR expertise today. In case you haven't heard, a DrGPCR University course is coming soon. Let's take a minute to explore what it's all about.
As you all know, there is a new DrGPCR University course coming up in February, and Terry is today with us to tell us a little bit more about that course. Terry, welcome.
Thank you, Yamina. Hi, folks. I'd like to tell you about a topic that, well, it was new in the 2000s, but now it's pretty well taken over GPCRs, and that's the question of biased signaling. So this is about a workshop. It's an hour and a half, and it covers this topic, and I'll try to let you know why I feel it's important. So when we think of agonists, and we're always concerned with selectivity, and that has always been the realm of the compound interacting with different receptors. But over the past years, we now realize that each receptor can now practice selectivity in the cell, and this is what we call bias.
Want to hear more? Go to ecosystem.drgpcr.com/GPCR-courses and enjoy a 25% discount on your registration with your premium membership. And now let's dive into this episode.
Good morning, everyone. This is Yamina from DrGPCR, and this morning I'm very excited to have with me Remi Janicot. And you're in Boston. We're early risers, so Remi, welcome to the podcast.
Yeah, thank you so much for having me. It's a pleasure to be here and share some of the work that I've been doing during my PhD.
I'm very excited to have you with us. So how about we start at the beginning? Please let us know who you are, what do you do? And I kind of sold it, telling people that you're also in Boston. So let's go from there.
Yeah, so just a little bit of my background first. So I was born in France, grew up in Belgium. So until I was 18, I was in Europe. And then I had a passion for basketball and for science. And so I want to combine these two. And so I decided to move to America to go to university, where I played all 4 years on the varsity basketball team, and also obviously completed a high-level academic degree in neuroscience, where I was also on the pre-med track at a small school around Philadelphia. And then after college, a lot of students go through this, but I was unsure whether to go the MD or PhD track. And so I decided to get a job at Johns Hopkins as a lab tech to get more experience of what full-time research would look like. And so that experience really convinced me that going the research way was right for me. So I applied to PhD programs and decided to move to Boston University in August of 2020 to start my PhD in the Department of Biochemistry and Cell Biology, and more specifically in the lab of Dr. Mikel Garcia Marcos. And he investigates, obviously, GPCR and G protein signaling, otherwise I wouldn't be here, but in a wide variety of models and contexts. And so, yeah, that's where I've been for the past 4.5 years now.
Wow. I think you're our first guest who came to the US so young and has, matched the love for basketball and science. So.
Yeah, no, it's tricky to do during my college years. It was hard, but it teaches you, time management. It makes you have a balanced life and forces you to be efficient when you're working, because you have that limited time and you're committing, 20 hours a week to basketball, which can be mentally and physically exhausting, obviously. So yeah, it's not an easy thing to do, but I'm glad I did it, and it was a great experience.
That's fantastic. This is, I think, anyone listening to this would be amazed at hearing the story. When you were a child, did you, considering your love for basketball and the fact that you were able to come to the US from Belgium and do this have this dual life when you think about it, but it's two sides of the same coin when it comes to that. Did you, as a child, love science? Or
Yeah, so I always had a knack for it. I don't know if it's because I had good teachers growing up that inspired me. I think that's a big deal. My dad does have a PhD in biochemistry as well, and he worked in pharma all his life, in oncology research, R&D projects. And so he never pushed me to go into science in any way, but I'm sure that somehow influenced me still. I was around that all the time, and I would hear his calls and hear him talk about work, so I'm sure it influenced me in some ways. But yeah, I think it's more personal interest that got me into science, and a fascination of how the human body worked, and at a cellular level. I thought it was really interesting how things have evolved in this way. And
was it more of a biology inclination? Sometimes we have guests who have more of physics or astronomy type of inclination as children, and they gravitate towards biology. But what was it for you?
No, for me, I think it was always like cellular biology. I really thought it was cool how all the mechanisms had evolved and how complex it was, but at the same time, pretty beautiful and simple in other ways, how things worked inside the cells, and one thing turns another protein on or off, and how that triggers an entire pathway downstream of that. So yeah, it's the complexity of it that I thought was quite beautiful, I would say.
I agree. I feel the same way about, for example, whenever I see a cat and it has different colors and it has different combinations and different patterns are there fur, my thinking is, oh, there's a gene that's get activated and activated, and it gives you the end goal, which is this beautiful animal with all sorts of colors on them.
No, exactly. It's really interesting, all of it, and obviously GPCRs and G proteins are part of that and related to it.
And they do. There is always a GPCR involved in whatever you're talking about. I wonder.
That's what I tell people too. Whenever they ask me what I'm doing, is I tell them, GPCRs without even about them, because they're involved in everything. So
exactly. And then, which makes me wonder if it's kind of a chicken and an egg thing. Are we always thinking or bringing it down to a GPCR because we work on GPCRs, or is it the fact that GPCRs actually are involved in a lot of things? I think it's kind of a little bit of both.
Yeah, I'm sure there's a little bit of both in that. Yeah, that's true.
I would love to hear about your time as a research assistant at Johns Hopkins. How did you? You mentioned this that once you completed your degree, you had the choice of MD route versus PhD route. I think a lot of people who are going to be listening to the podcast have gone through these questions of, what do I do with my life now that I've finished this degree? But what made you decide to take a step aside towards trying out working in the lab, and how did that happen?
Yeah, so even during my undergrad period, I was part of a lab where I did like a couple of hours of research every week. Again, that's on top of my studies and basketball. I would go into a lab a little bit. But it has nothing to do with being in a lab full time, right? I think there's a very, very big difference when you're an undergrad of going into a lab a couple of hours per week versus being full time and really seeing a process go from start to finish. So I think there's a big difference in that, and I got some of that during like a summer fellowship that I had done. And so I wanted to get more of that experience, that full-time lab experience. And the lab that I joined at Johns Hopkins was also great because the professor that was leading the lab was an MD PhD. He still saw patients and things like that. So I went to shadow him a couple times. So I also saw the clinical side of it in addition to the full-time research that I was doing. So that's what really drove me to do this, to get both sides, both views, and see what I like the most. Yeah.
I love it. I love it.
Yeah.
I always have these types of questions as to how did you plan these things, but I can hear that you're very deliberate about your choices and you gave it a lot of thought. And I'm assuming you saw this at home as well from your dad.
Yeah. No, I'm sure. I'm very target oriented. So like when I set myself a goal, when I set myself a target, I think pretty carefully about how to get there. And so yeah, doing this work as a lab tech at Johns Hopkins was the best way for me. And it was a great experience. I did research on pediatric epilepsy. Again, looking at GPCRs without even knowing I was looking at GPCRs. We were looking at neurotransmission. It was an electrophysiology lab. So obviously GPCRs are super relevant in that. And yeah, it was really good experience where I was able to lead my own projects, and the professors I was working under really entrusted me with some great projects that I could lead. So yeah, it was a great experience.
I love it. So let's put a pin into the GPCR aspect. I'm really curious to hear about, and this is one for me, but also one for anyone in a PhD or in a postdoc. How do you think, how do you plan? How do you set your goals? And what, if you can share with us a little bit more about the process? And I think this comes out of your busyness but because you were doing a degree, that you had basketball, you had lab. And I think it's important to stop and have talk about it a little bit, because a lot of us in general in life could benefit from that. So
yeah, I think the best way, honestly, is talking to people. Reaching out to people who are in certain careers, asking them how their job is, what do they do on a day-to-day basis, and then thinking about whether or not that could be a good fit for you. And then if someone inspires you, if someone seems like they're loving their job and they can't like say enough good things about it and inspires you, then just follow that, see where it leads you. So I think, yeah, networking, talking to people is one of the best things I've done pretty early on in my career, and I still try to do. And maybe that's another point, but maybe it's something that's not emphasized enough during PhD training. Yes, there are conferences where people go talk and interact with other scientists, but I don't think it's emphasized enough to students to really reach out to people, go on LinkedIn, send messages to random people you don't know, and ask them if they have like 15 minutes to chat. Or talk to professors if they have 15 minutes to chat. Everyone's busy, it's hard, and most people probably won't answer to you, but try. Get out there, talk to people, see what's out there, because as a PhD student, you have tons of options. And so, yeah, that's my main advice. I would say.
I love it. I love it, because I've said this. I think I've said this over and over and over again on different podcast episodes, but I'm glad that it comes from you as a PhD student, because I feel like sometimes when you say when one person says one thing, it might resonate with one group of people, but when it comes from a peer, then it might resonate differently. So I'm glad, and I love the approach. I love also the openness of saying, I'm just gonna try and send them an email or a LinkedIn message. And thank you for saying LinkedIn, because I think a lot of academic scientists at all levels don't have a LinkedIn account. And they should.
Yeah, that's the point I was trying to make. I think in academia and as a PhD student, like the networking part of it is undervalued, in my opinion.
It is, and I think it's a matter of universities also making the effort of providing the opportunity to learn about all of these networking options.
Yeah.
And it's important. You never know who you're going to meet. You never know who you can help.
Exactly. Yeah.
And you never know down the line who's going to call you and say, Remi, I have a super project for you, or I have a job for you, or you introduce. You never know.
Yeah. No, I totally agree with that. Yeah.
I love it. I love it. So how did you pick your current PhD lab?
So the PhD program that I joined at Boston University has a rotations system. Do you want me to explain what that is
A
for the
little, a
or
little bit.
okay.
Yes.
So basically during my first year, I did 3 rotations in 3 different labs on our campus, on the BU Medical School campus. And they let students do that so that they can then pick whichever lab is the best fit for them. So during, I think it's 8 weeks, you rotate in a lab. You're usually attached to like a PhD or a postdoc, and you try to learn how the lab works, what the culture is, what kind of projects you could be working on as a PhD. And then at the end of your 3 rotations, so at the end of your first year, you decide which lab you want to join full time. And so I did all these 3 rotations, and my rotation in the lab of Mikel Garcia Marcos was the one that I had liked the most. I worked with a former postdoc now who was really great mentor to me. I like the project. I like the lab culture. Everyone is a very hard worker. Mikel leads by example. He works as hard as anyone else. And so, yeah, I liked that everyone had a drive to move forward and move forward quickly with science. Science is hard. It can feel slow, but people in the lab seem pretty motivated and got good results. So that's always motivating as well. So that's why I decided to join the lab.
I love it. And you make a great point. And I think this is a good thing about the quote unquote American system of rotation. I don't know anywhere else. I know that when I was doing my master's and PhD in Canada at the University of Montreal, we didn't have this opportunity. During my undergrad, we had the opportunity of doing a summer internship. And that was it. You didn't have the chance to meet other PIs. And most of the time, people would stick and do a master's or a PhD in the lab where they did a summer internship.
Yeah, no, I like this idea of rotations. And I think some students come in with like a predetermined idea of, oh, I want to join this lab, so I'll rotate in this lab and then end up picking it. So that still does happen. I did not have that mentality. I went into every rotation with an open mind. And to be fair, when you come in as a PhD student, yes, I had some background in neurology, blah, 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 but I really didn't know anything about science. And I think most students don't. So I think it's important for students to keep an open mind and see if you like the topic. You never know. You could be surprised if you have an open mind.
I agree. I think going at it with an open mind, a lot of us when starting a PhD, you have no idea what you get yourself into.
Yeah, exactly.
On so many levels, but at the same time, one thing I'd like to add to that is keep an open mind, but also trust your gut. If you end up doing a rotation in a lab where, science might be good, but the mentorship is not, or, you need to make sure that you feel comfortable there, because you're going to be spending more time with your colleagues than with your own family at the end of your PhD.
Yeah, no, for sure. It's an important decision, and 8 weeks may be a little short sometimes to make that big of a decision, but that's why you have to try to spend as much time in the lab as you can during that rotation to really get a feel for it.
Exactly. So tell us a little bit more about your PhD project. I'm curious to hear.
Yeah, so in Mikel's lab, he works on a wide variety of models, diseases, etc., related to GPCR and G protein signaling. My specific projects are more around tool development. So I'm developing new sensors that can detect G protein signaling in ways that were not attainable before. Basically, I'm trying to improve on previous technology and address some limitations in the field. for then other labs to use those tools and move their studies forward. So I can talk more into the specifics of
Yes.
so they're breadth-based biosensors. So I feel like most of your listeners will know what breadth is.
Yeah.
And so some of the limitations traditionally have been that people measure downstream readouts, which can be skewed by amplification or crosstalk events, so that can skew your results. And a lot of the biosensors that currently exist are really only applicable to cell lines, which have some value, but obviously if you're thinking about physiological relevance and what happens in real native systems, cell lines don't necessarily replicate the complexity of in vivo cell mechanisms. And so the work that I've been doing during my PhD is really to push for and try to develop sensors that measure G protein directly. So we measure G alpha, GTP, which is the most direct way of measuring GPCR activity. And we make tools that are compatible with a near endogenous system. So they're compatible with primary cells, and we've just published a paper on a new sort of biosensor called 1Go sensors that are publicly available on AdGene. And we show that they're super versatile tools, that they do work in cell lines, they work great, but they also, their main advantage is they work with endogenous GPCRs in a wide variety of primary cells, including like human cardiac fibroblasts, mouse lung fibroblasts, mouse neurons, human endothelial cells, etc. So super versatile tools and really push towards native or close to native systems, so that we can study the real biology, I guess, of GPCR signaling.
I love it. And you're right. Cell lines are great because they grow fast. You can screen, you can play around with them. But at the end of the day, whatever happens in the cell line might only happen in the cell line. So you need to have primary cells, and beyond that, at that point, you're in animal models. But it's always nice to be able to probe a system where you have native expression of your GPCR.
And we've shown that in the paper. We've shown some actually pretty surprising GPCR behavior when you study it at endogenous level in primary cells versus what could be expected from what is known in cell lines, basically. So it really does matter, and that's what Mikkel and I have been trying to push forward.
I love it. I always ask this question, but now that you're developing tools and you're focusing on G proteins, any favorite G protein or GPCR?
Yeah, so it's I saw it that you in the questions that you had sent. So it's hard to pick because when I develop tools, I try to make them compatible with as many GPCRs as possible, right? We want the entire field to be interested in these new biosensors. So in these 1Go sensors that I was talking about, we validated them with like over 70 GPCRs that they worked, and we're able to detect responses from over 70 GPCRs. Now, if I had to pick, I have done some research on the protease activated receptor 1, PAR1 receptor. And it's actually one of the receptor that we focused on when studied endogenously in primary cells, and it had some pretty interesting behaviors. So, for example, when you look at it in hex cells, so in a cell line, it's known to couple to GI, GQ, and G13 and to activate them. So it's a promiscuous receptor. But then during our studies, we looked at this receptor in different types of primary cells. And depending on which cell type you looked at this receptor, the activation profile of it was drastically different. So in cell type A, it would activate GI and GQ great, but not G13. In cell type B, it would activate G13 and GI, but not not GQ very well. So like the activation profile of the receptor when studied again at an endogenous level in primary cells was completely different. We also looked at this receptor in more of a biomedical model, in a model of fibrosis. And we saw that again in the disease model versus control cell, the activation profile of this receptor was completely changed. And so yeah, that's a receptor that I've been focused on during my PhD. But again, the tools that we develop are compatible with, I can't say all GPCRs because we haven't tested all GPCRs, but to a wide range of GPCRs. And
I love it.
these examples that I've given you about the PAR1 receptors, we also have examples of other GPCRs that also have striking behaviors when you study them at an endogenous level. So it's I'm not saying the PAR1 receptor is the only receptor that has these features. I think it's a pretty prevalent feature of GPCR signaling in general.
I love it. And I have you looked, and I don't remember. I do remember seeing the paper. I do remember going through it very quickly. But have you ever thought about PAR1 in platelets, or have you looked at platelets? I don't know if it's even a possibility to use it, because PAR1 activation actually induces platelet aggregation.
Yeah, no, that's correct. We have not done that. But PAR1 receptor, yes, it's involved in coagulation and platelet aggregation, of course, but it's also involved in cancer development and in fibrosis and in a lot of different diseases. It's pretty widely expressed and at pretty high levels. So yeah, it's a good system for us to study it. But we have not looked at it in platelets directly now. Yeah.
When you mentioned having different activities or different G proteins activated depending on which cell line you're looking at, I think it's a great opportunity to specifically target receptor G protein complexes in that disease state. So if, for example, in fibroblasts, you have one G protein involved, then you can think about that conformation.
Yeah, no, exactly. So that's what we hope will happen with the tools that we develop, right? So if a lab is interested in fibrosis, instead of if you're looking for a drug to treat fibrosis, instead of looking for that drug in HEK cells, do it in lung fibroblasts from mice, or even like cardiac fibroblasts from humans that you can order online, and then test that drug in its real native context, and that will give you more accurate representation of what is really going on versus a HEK cell, right? And so we hope that people will use these tools this way to move drug development forward and move just GPCR signaling forward, and in general, just at a molecular level, how we understand GPCR signaling. Yeah.
I love it. So on the page where this podcast episode will appear, I don't know if you've already filled out your guest form, but if you haven't, or we can look it up as well. Let's put in the link to AdGenes where people can get access to these plasmids.
Yeah,
I think it's going to be very useful.
Yeah, no, for sure. That would be great. We're happy to share those tools, and hopefully other people will like them as well. We've gotten some feedback already from. We went to ASPET a couple months ago, and some people were already using the tools and it was working in their hands. So that was also super nice to hear. That during my PhD I developed something that other people were using, and I was happy to hear that and proud of it. Yeah, it was a good feeling.
That's fantastic. One thing I wanted to ask, you mentioned this very briefly, that you joined your PhD lab in August 2020.
So I joined the PhD program in August.
Yes.
But then I did rotations, and then
okay. So still August. It's not the August, is the 2020.
Oh yeah,
aspect. It's in the middle of of COVID. So I'd be curious to hear a little bit more about what did that look like when you joined your PhD program compared to today, where COVID is still present, but not the same. We're not in a pandemic anymore.
Yeah. So obviously, it was an interesting time. I moved to a whole new city. I didn't know Boston before moving here, so I moved to Boston during COVID and started my PhD program during COVID. So moving to a new city, first of all, during COVID wasn't super like fun, I guess. It was obviously harder to meet people. It was harder to interact with people, and that was also true, I think, for my PhD program. And I do think, obviously, it wasn't BU's fault. They were following the rules and they did the right thing, but I do think I missed out on bonding with my cohort, because a lot of the classes were via Zoom, and because everything was either hybrid or all via Zoom, I really didn't get a chance to interact with my cohort, like, I don't know, after or before classes. And then the lab itself, by the time I joined, it was pretty much running full time. People were obviously still wearing masks and social distancing, but it was still, people were still at work regular hours. So I did get a chance to interact with everyone in the lab and talk to them, even with social distancing and masks. So my lab experience was okay. My first couple of months of like taking classes and getting to my cohort, I do think I got some things taken away from that because of COVID, but obviously it's okay. It is what it is.
Exactly. What's done is done. Now, I just wanted to touch base on that because we were continuing in our discussion, I remember that you said 2020.
Yeah.
And that is the year.
No. Moving to Boston, I would say was the hardest part of it. Moving to a new city where you don't know anyone during COVID.
Exactly, and you have no chance of knowing anyone because you're COVID. I do remember when
I'm happy now. Happy with the lab, and I think Boston is a great city for anyone out there thinking about doing PhDs. The Boston University School of Medicine has a great program, and it's in a great city. So yeah.
I concur. I love Boston. We moved here in 2019, almost a year before COVID, and the minute we set foot in Boston, I said, okay, this is it. Loved it a lot, and I think it's a beautiful city. A lot of university opportunities, academia as well. You drop a pin and you hit a couple of biotech companies on the wall. You dropped that pin in the Boston area. All right.
Exactly.
I know we're almost at time. We talked a little bit about advice for young scientists, but before we go back to that, any aha moments that you had in your career so far? Anything that got you to where you are today, where you say, had I taken a left turn, we wouldn't be talking today, or a right turn?
Honestly, I don't think so. I do plan ahead, and I do think ahead of time and make long-term decisions, but the way I've taken my career and education so far is really, like I said, by talking to people and then following whatever path gets open. And so I always keep an open mind about new opportunities, what else is out there. I'm always on the lookout. And then if something catches my attention, then I go towards that. So I don't think there's one critical moment that really changed drastically my direction, because I'm always moving direction by myself. So I don't think there's one critical like inflection point that I would say. Obviously, this PhD that I'm doing right now is going to be a huge achievement when I finish it, and I'm sure when I look back in 10 years, in 20 years, I'll still remember this PhD as really a formative period in my time. And Mikkel's lab is great from that. I'm getting towards the end of my PhD right now, and I can already see like the growth that I've been on since starting the PhD. So it's really satisfying to see. But yeah, for now, maybe it's because I'm too young and I don't have enough experience, but I don't have any critical moment. obviously moving to America as an 18-year-old kid was something.
Exactly. That was a critical moment, and the fact that what from our conversation, what I see as critical moments. One is moving alone at 18.
Yeah.
The second one is taking the time to work in a lab at Johns Hopkins.
Yeah.
That was also a critical moment because that allowed you to decide PhD or MD.
Yeah.
And then I think maybe the other critical moment that comes through the conversation is you picking Mikkel's lab.
Yeah.
Because,
No, obviously those are all very important moments in my life and decisions, but I don't know, when I think about, I don't think about them this way. I just think of them as that's where life brought me, and I'm happy to be there.
I think the way it sounds like is you're always on the move. You're always keeping an open mind, which is fantastic. And it's an opportunistic type of approach as to once you're presented with an opportunity, you think about it. Does this make sense? How do I feel about it? And then you go for it. Which is great.
Exactly. Yeah, that's my philosophy. Yeah,
I love it. What's next after your PhD, if you know?
So I'm getting an idea. Yeah, well, it goes back to talking to people and networking and thinking about what is out there. So I love science. I love talking about science. I love the ideas behind it. It's important work. Now, doing science and being on the experimental side of things, I don't think I want to follow that career trajectory. And so during my PhD, I've also had some experience looking at the business side of science. And so my goals now are to combine both business and my scientific knowledge and skills to go more into the investment side of things. So biotech investment, biotech VC, and go into that career path.
It's a very unique and very different way of thinking about things, but it gives you the opportunity to think about that 30,000 feet view of where does the scientific question go and where should the investment go as well. So I think
and I think, I mean, as scientists, we're all curious people, I think, inherently. And when I started, again, talking to people and learning more about the business side, I realized that there was this entire ecosystem, an entire field that I knew very little about. And that caught my attention, and I started listening to podcasts. I started taking some classes. I started trying to network with people. Again, goes back to the networking thing. But yeah, I realized there was this entire world that I knew little about, and I wanted to learn more about it. And it turned out that I think it's also pretty interesting what goes on and how it works and the dynamics between the market and pharma and small biotech and like the customer, obviously, or the patients. So yeah.
Have you heard about the book Building Backwards to Biotech?
I have not. No, who is by? Do you know?
Stephanie Wisner.
Okay.
So I actually bought the book because she started out as a PhD student who was also thinking about what to do with her life. And so she had a lot of mentors. And I haven't finished it, but one scene caught my eye is that she was on the phone with one of her mentors who told her there is a networking event that you should go to. It's happening right now. You should go. And that's where she met a lot of CEOs, a lot of people in business, and she was able to get an opportunity. She went to business school as well, but she got an opportunity to work at VC firms and to understand how they build, they invest in biotech. And so the book explains very nicely what is biotech, what's the difference between biotech and biopharma, and how do VCs think about this, and what's the life cycle of a drug. So I'll send you the link.
Yeah, that would be great. Yeah, that would be great.
I will send you the link because I think it might be
worth that would be interesting. Yeah,
diving into it, considering your aspirations, which is super.
No, for sure. Thank you.
Of course. Any other advice to scientists? I think we talked about a lot about keeping an open mind, being able to communicate with others, networking, LinkedIn. Although this is not an open ad for LinkedIn, but it's a really useful platform. One thing I wanted to say thank you for is that once you booked this podcast episode, you did connect with me on LinkedIn. You did send me a message, and I really appreciated that a lot. So thank you for that.
Yeah, no, I mean, like I said, I knew your podcast before even getting the invite, so I thought it would be a good idea also to keep up to what you do and how you do things. So yeah, it's my pleasure to connect.
Thank you. Any other advice for scientists, for PhD students?
For PhD students, I mean, I don't know if it's an obvious one, but a PhD is hard, and I think it's supposed to be hard. And that's okay. It can feel long. It can feel overwhelming at times. I've gone through those phases as well. But that's part of the learning process. You learn resilience. You learn how to stick through the bad times and ride the highs and ride the lows. And I guess a big advice that I would have is try to make progress even on the bad days. When you do experiments, sometimes we've all been there. You can have a great day where everything works fine on the first try and you're done in an hour. And then you can have a bad day where, I don't know, your cells are not behaving well and you're not getting the results that you want. And I think on those days, it's important to keep your focus and make decisions in the instant to get at least some data, make some progress. So yeah, it's easy to make everything work on the good days. Try to get as much done as possible on the bad days as well.
Yeah.
I think it's my main advice.
I love that. And it's all about also making the difficult decisions. If the cells are not up for it, and you can tell the cells are not up for it, just throw the cells out and do something. Exactly. It could be something just as boring as aliquotic things or organizing stuff, because the next time you're looking for something, you will know.
No, for sure. I agree with that. But yeah, PhD is hard. Try to find a good mentor. Talk to your lab mates also. They're going through the same thing. If you're having a bad time, or if you're struggling, go talk to your lab mates. They're going through the same thing. They can help you. But also, as part of that, enjoy the ride. And I'm at the end of my PhD, and looking back at all the progress that I've seen and that I've done, it's really satisfying for me to look at that. So you do have to keep that in mind early on in your PhD, I think, and in the middle. That you'll look back at it and you'll be able to be proud of yourself in what you've accomplished.
Agreed.
So, yeah.
Last question. What should we title this episode? It's a tough one.
Yeah. So I was thinking of something like developing new tools to uncover surprising GPCR signaling patterns. Because again, the thing is, your readout will be different based on the tool that you use, right? And so when you use tools that have a higher fidelity in what a GPCR is actually doing or what it's actually triggering, you might find some surprising data, and that's what we've shown in our paper with using the One Go sensors, and I think we only touch on a couple of examples that we stumbled upon, but I think there's much more out there that can be discovered.
I love it. I was thinking more something along the lines of, something that includes basketball, G protein, basketball, One Go, G protein signals, something really catchy in that sense.
Well, you've been running this show for longer than I've known, so yeah, if you have a different idea, I'm
you-
I'm open-minded. I think this has come through this episode as well. So
Yeah.
if you have suggestions, I'm sure.
With your permission, I'd like to include the basketball in there because I think people will be like, "Oh, Dr. GPCR podcast and the word basketball in there." Do you still play, by the way?
Yeah, you can't see this via like video call, but I am 6'7" or 2 meters tall for the European listeners. So yeah, that also makes sense with the basketball part of things.
Well, when you said basketball, my first thought was, okay, I would have to look up to you because I'm barely 5 feet, so 150.
Yeah.
So
Yeah.
There's that about 50 centimeters of difference in height. Do you still play basketball?
Every once in a while, but not that often, honestly. It's hard when you come out of college, at least in America, to like find a team to play on where you can have like competitive basketball.
Mm-hmm.
So I still work out almost every day, and I still do I ran a marathon last year, so I'm still very active and very very active, but basketball not so much. Yeah.
Well, who knows? Maybe once you can create the investment or VC basketball team.
Yeah, exactly.
Awesome.
Yeah.
Thank you so much, Remi. Don't go anywhere. We're going to stop recording.
Okay.
I really appreciate your time. I really loved our conversation.
Yeah, no, this was great. Thank you for having me. It was great.
I need a favor. If you enjoyed this episode, please click the like button. And if you like the podcast, consider subscribing to our YouTube channel. Many of you come back to watch our videos but aren't subscribers yet. One click goes a long way. All the information about DrGPCR is in the description. Find all our fantastic features and everything you can benefit from becoming a premium member. And while you're on it, check the DrGPCR University courses and share them with your network, colleagues, and friends. We also want to hear from you. Is there anything missing from our ecosystem? Can we make it better? Email yamina@drgpcr.org or email our team at hello@drgpcr.org. Thank you so much for joining us in this podcast episode. If you're still there, we also want to take a minute to thank our team members: Yamina, Attila, Montserrat, Cam, John, Yatsu, Mark, Ivana, and Andreina. If you like our podcast, you can leave us a 5-star review on Apple Podcast. Until next time, and stay safe.